Space junk is a critical issue facing humanity. Imagine a hailstorm, but instead of ice, it's millions of pieces of metal, traveling at thousands of miles per hour. Defunct satellites, spent rocket stages, and collision fragments pose a significant threat to our space infrastructure. The European Space Agency estimates over 130 million objects larger than 1 millimeter are currently in orbit. These objects travel at speeds up to 17,500 miles per hour. Even a small piece of debris can cause catastrophic damage upon impact. This constant bombardment poses a serious risk to operational satellites. The International Space Station also faces continuous threats from space junk. Where does all this space junk come from? The answer is, unfortunately, us. Since the dawn of the space age, we have been launching objects into orbit. The most obvious culprits are defunct satellites, no longer functional. While some are deorbited safely, many remain in orbit. Spent rocket stages are another major contributor. These stages often remain in orbit, posing a collision risk. A significant portion of space junk consists of fragments from collisions. When objects collide, they shatter into thousands of smaller pieces. Even small items like bolts and paint flecks can cause significant damage. The dangers posed by space junk are not merely hypothetical. Collisions between objects in orbit have already occurred, and the consequences can be dire. One notable example is the 2009 collision between the defunct Russian satellite Cosmos 2251 and the operational Iridium-33 communications satellite. This high-speed impact created thousands of new pieces of debris, adding to the overall population of space junk. This event highlighted the very real danger of a phenomenon known as the Kessler syndrome. This theory, proposed by NASA scientist Donald J. Kessler, suggests that as the density of objects in low Earth orbit increases, the probability of collisions also increases. Each collision generates more debris, leading to a cascade effect that could eventually render certain orbital regions unusable. This scenario would have devastating consequences for our reliance on space-based technologies. The threat of space junk is not limited to objects remaining in orbit. While most debris eventually falls back to Earth, burning up in the atmosphere, larger pieces can survive re-entry and pose a risk to people and property on the ground. Most space debris that survives re-entry lands in the ocean, which covers over 70% of the Earth's surface. However, there have been instances of debris landing on land, sometimes in populated areas. In 1978, the Soviet satellite Cosmos 954, powered by a nuclear reactor, re-entered the atmosphere and scattered radioactive debris over a remote region of Canada. This incident highlighted the potential for space debris to cause environmental damage and pose a threat to public health. While the probability of being struck by a piece of falling space debris is extremely low, it is not zero. As the amount of debris in orbit continues to grow, so too does the risk of such events. Addressing the growing problem of space junk requires a multifaceted approach, involving international cooperation, technological innovation, and responsible space practices. One key strategy is to prevent the creation of new debris in the first place. This involves designing spacecraft for end-of-life disposal, either by deorbiting them safely or moving them to graveyard orbits where they pose less of a risk. Another crucial aspect is tracking and monitoring existing debris. Ground-based radar systems and telescopes play a vital role in identifying and cataloging objects in orbit, allowing for collision avoidance maneuvers. Beyond these preventative measures, researchers are actively developing technologies for removing existing debris from orbit. Concepts include robotic arms, nets, harpoons, and even lasers that could capture or deorbit debris objects. International cooperation is essential for addressing this global challenge. Sharing data, coordinating mitigation efforts, and establishing international guidelines for responsible space operations are crucial for ensuring the long-term sustainability of space activities. The issue of space junk is a stark reminder of the impact human activities have on the environment, even beyond our planet. However, it is not an insurmountable problem. By acknowledging the risks, embracing innovative solutions, and fostering international collaboration, we can mitigate the dangers posed by space debris and ensure the responsible use of space for generations to come. The future of space exploration and our reliance on space-based technologies depend on our ability to address this challenge effectively. By working together, we can clean up our act in space and ensure a clearer path for humanity's continued journey beyond Earth.